Hello, this is Carlo.
Hi, this is Ricardo.
Today we're going to talk about ways to web development in the Wolfram language. More specifically, we're going to concentrate on 4 functions, 2 that are new in 10.3 and 2 that are not yet released. You will see them in the next release of the Wolfram language. The first function is not really new in 10.3, it's actually HTTP Response. HTTP Response existed before as a symbolic wrapper for HTTP responses, and we've now greatly redesigned the way it works and the way it looks for it to be more convenient for developers. The other function we've released in 10.3 is Generate HTTP Response. Generate HTTP Response is on one hand, the mechanism that Cloud Deploy uses whenever you have some special heads such as API function and form function to return an HTTP response. But it's also a tool you can use locally to debug your deployment in the same kernel you're actually working. The 2 upcoming features we're going to cover are URL Dispatcher, which is a very simple yet powerful URL router, and web server, which is a local web server that you can use to test your deployments before actually putting them on the cloud.
Let's get started with HTTP Response. HTTP Response already existed in the previous layout of Mathematica in 10.2. It was just a symbolic wrapper, but now it's a proper object. The way it works is that the first argument is the body, supposed to be the body. It can be either a string or a list of bytes. And the second argument is an association containing all metadata of the HTTP response, such as the content type, which is an header, and status code or another thing. So as you can see, what we have done is done a summary box, and this summary box is basically a convenience for you to quickly inspect what are the most crucial information about the HTTP response. So for example, you can see the verbose status description in this case is okay, because it's a successfully response of with status code 200, and the content type. When you press plus, you can inspect basically the body. By clicking it, you can print it, and it says there are no headers here. And when you click on 200, you get the browser response for what the browser will show basically for your generated HTTP response. So as we were saying, you can ask for properties by doing properties. The summary box is inside the HTTP response. Here you can see that is displaying a different color for different status code. So it was green for success code, like 200 and 300, and 400, which is a client error, is an orange color, and 500, which is a server error, is red. And now let's talk about Generate HTTP Response. Generate HTTP Response is is a top-level function new in Mathematica 10.3, which you can use on everything, and is guaranteed to return an HTTP response. So for example, here if we use Generate HTTP Response over delayed, you can now use your local machine to simulate the cloud behavior, and everything is happening inside your local machine. So as soon as you execute this function, the HTTP response is generated, and if you click here, you can have a preview of the HTTP response. So now you can also verify that when you do cloud deploy over the same object, the HTTP response is effectively the same. And now, for example, we can use also generate HTTP response to simulate behavior of an API function. In this example, we wrote a very simple API function, which is basically the API function is expecting just one argument. which is supposed to be an integer, and then with this integer we are doing some kind of computation, and we are about to export the result in a JSON format in order to consume this API function in an external program. So when we run generate HTTP response API, the HTTP response is generated, and then here we are asking for the body, and in this case the body is exported in JSON. So since when you go to the page of an API function you are sending no argument to the API function, the API function is failing. So in this case the API function is failing in a JSON way. So it's returning a JSON response which says that the success that there is an error here, and then also is serializing all the fields that are inside the API function. This is a useful feature because if you are consuming this API from an external program, then if something goes wrong, so the input is not correct, you may want to display, for example, some message to the user that can help fixing that. So in this case the problem was that the field was required and there are no input, and so you can use this thing in JavaScript, for example, to display the error to your user. And generate HTTP response get also a second argument, and the second argument is the HTTP environment. So basically is an association that got the very same data inside of HTTP request data. So when you use the second argument you are effectively simulating another HTTP environment. So in this case we are simulating the fact that there is a query string with x goes to 10, and then we're asking again for the body, and now the API function is returning a successful response with the result of the computation.
Now, generate HTTP response is a very interesting tool for debugging your local deployments, but that's not the end of the story. One of the reasons we've developed generate HTTP response is because this new architecture now allows for things that were not previously possible in Cloud Objects. For example, suppose you wanted to have a Cloud Object that behaved like a form or like an API in different contexts. Previously, the only way of doing that was basically redeploying another Cloud Object with the API or with the form every time and then redirecting the user to it. Now it's possible to do things a little differently, and a nice way to think about this, if you're familiar with the Mathematica typesetting behavior, is makeboxes. Makeboxes is used by the front end to have a way to render each expression in the notebook in a very nice way. And the way it works is by recursing on the expression and creating boxes for each part of the expression. The same thing happens with generate HTTP response. You have generate HTTP response over an expression in the context of a HTTP request, as Ricardo has shown previously for an API, and you drill down the expression until you get something that is an HTTP response. If you are not there yet, then you keep recursing. And so, for example, this is what happens here. You have delayed. Delayed is sent as is, held to the cloud platform. Inside there is an if, and this if the condition is evaluated, we're looking at the HTTP request data, looking at the query string, and if there is a mode and that mode is set to API, then we return an API function. Otherwise, we have a form function. So if we visit this cloud object, here's the default behavior, but if I change this and I add underscore mode equals API, then boom, I have the API. And both the API and the form function are fully functional. So moving forward, another thing we can do, for example, is suppose you want to have a form function that looks completely differently according to what the time of the day is. Well, in this case, we can just add an if here. The whole form function is delayed, so its evaluation is waiting for you to visit the cloud object. And if we're during the day, then your API, your form function will look red. If the sunset has passed, then your API, your form function will look black. Another thing that has been allowed by this big refactor of the way cloud objects work is for the easy definition of new symbols that behave in a special way when cloud deployed. And for example, one new symbol that we've added is URL dispatcher.
URL dispatcher is a very simple URL router, but still a very powerful one. It's basically very common inside every web framework to redirect basically the view, to dispatch the view according to a router, which is basically regex over the path. So if the regex matches, then a function is executed. Something very similar is happening here. So for example, if you visit something like /API, then you go to an API function, and over a /form you're going to a form function. But now you can combine this syntax with the string pattern syntax that we have inside Wolfram language. And so for example, here we are matching an URL that is starting with a slash and then one or more digit character. So if this is matching, then we are using this part of the string, which we call ID, to redirect the user. In this example, we are doing a redirect to IMDb. So now, if you run generate HTTP response over rules, in the first case, the second argument can directly be a string. If it is a string, then it's supposed to be the URL you are visiting. So in this case, basically the path is /123. So the rule we wrote here is matching, and then we're returning. So the generate HTTP response is returning a 301, which means a redirect. And if we run again with a different URL that is not matching, then we get a 404 because the page is not found. And now, on top of URL dispatcher, we can start building something more complex. For example, the application that Carlo wrote, and maybe you can speak about it a little bit.
Now, suppose we wanted to use Wolfram technology to build a full website. Namely, where this example is the website of Royal Academy of Science in Sweden, which is the organism that gives out Nobel Prizes. So now we have a top-level URL dispatcher. There is a contact form function, which takes an email and a message and then throws it away, obviously. And then there is a form page, which is a new function in 10.4 that you should definitely check out, which works as travel directions to the Royal Academy. And then there is an API function that is used for showing images of Nobel Prize winners with a nice effect. And then last, there is this URL which will match any string which is none of the above and is composed of letters. And we use this sequence of letters, interpret it as a language, and we use it to translate a welcome message to another language. Now, this is not a terribly complicated example, but still, we have links, we have several pages, we have, actually, since here you can put whatever you want, you have a huge number of possible URLs. And it's very inconvenient to test them all by just doing generate HTTP response on each and every one of them. And you have no guarantee, for example, that the links from one page to the other will work, because the links, if you run each page separately, you don't have the website as a whole, and APIs will not work, or at least you will have to provide the query string as well. So all of this is not quite as soon as you get something which looks more like a real website, you cannot just test it like that. So one thing we are going to add very soon is a new function called start web server. Now start web server will just start a server on the port of your choice, 7000 by default, which you can just visit, and you get a nice web page with a picture of a random Nobel Prize winner. You can see other ones by clicking here, and here it is. Or you can look at Marie Curie, and as you can see, this is an actual API function. So if you edit this and use another Nobel Prize winner, you will see another image there. Now there is a contact us form, and this is a real form that works. So for example, if I use this and submit, then it's going to complain because this is not a valid email. And if I put something that looks more like an email, then it will thank me for contacting them. So now if I go back to the main web page, you can also see how instead of if I don't want to see the default English behavior, I can translate the page immediately to say French. Obviously this is going to be an automated translation, so we cannot trust that it's good French, but bear with me please. Or you can translate to Japanese easily. And then you can, for example, visit the form page and say that you want to go from Rome to the Royal Academy, and built-in function travel directions in the Wolfram language will give you a rundown of how to get from Rome to Stockholm. Here it is. It's pretty long, but it's not that close. So so basically that's it. But one thing that is very cool is what Ricardo is going to show you now.
So, a little insight on how Start Web Server works on Mathematica. So, Start Web Server is development only server. Is not good for production use because it's not handling concurrency. It's not handling basically, so it's not production ready. It's a kind of web server that you're using just for development, which is very common inside of web framework to have a web server that is running with one command line. And so now we have it, and basically you can just evaluate start web server, and web server will start on your machine. Now the way it starts is that basically the server is communicating asynchronously with your current kernel. So even if the web server is running, your kernel will still be able to do computation as usual, so you can evaluate cell like normal. And the nice thing is that when you evaluate something, so for example, we have binded the web server to this symbol, which is called $Nobel site. But now as soon as we evaluate this cell again, we change the definition of $Nobel site, and now by just visiting the web server, we can see that now we get a different response. This is possible because basically all evaluation that are coming from the server to Mathematica are happening inside your local kernel in this particular state, and this is very convenient for developing because let's say that you find a bug, so you need to do some changes. You evaluate some code again, so you change the function. Now you can just go back to the browser, refresh, and that's it. You got the new code that you wrote running again. And this is happening only because basically, yeah, the evaluation is happening asynchronously, and this is not something that you can do in other web framework. For example, if you, I don't know if any of you is like familiar with web development, but for example, if you are working with Python or PHP, the way whole web servers are typically working is that they're launching a program on the background. They're launching a program on the background that is checking for inside your code base for changes. So as soon as you change a file, for example, they will start again the web server, which means that they need to compile and run again all the initialization code. And this is a process that can take, according to the size of your code base, up to some seconds. And it can be so it can really slow down your productivity when you're handling a big project. In this case, basically the initialization is happening one time, and then when you're doing changes, you are just changing your kernel state, and the evaluation are happening inside your current kernel. And this is why we think that this kind of web server can really speed up your your development while developing a web application.
What have we shown today? There are two functions which are new or improved in 10.3. HTTP response is now finally a full-fledged object with properties. It makes it easy to inspect whatever is happening with your HTTP response. Makes it easy to open the file in the browser if need be. Generate HTTP response is basically the make boxes for the cloud. It allows for much more powerful behavior on the cloud platform itself, and it allows you to debug your applications locally, which is nice and convenient because, for example, if you got something wrong, you get messages. It's a bit difficult to capture the messages when you're cloud deploying every time a new object. Upcoming features: URL dispatcher, which is a URL router. You get all the power of the Wolfram language string matching and all the simplicity of just replacement rules, which every person who has used the Wolfram language is familiar with. Local web server, very important tool in the belt of every web developer, and that's it for today. What we're trying to do here is we're trying to build a toolkit that works both for novices who don't know the first thing about HTTP requests and responses, and power users who actually do use JavaScript and HTML and just want to use the extreme power of the Wolfram language with entities, quantities, and all the knowledge-based computing. We want to have tools that work for all of them. And so, because of this, we would really like to hear from you, from suggestions and requests and anything that might be missing on what we're doing.